You are listening to The Vocal Technologist. Spoken tech for your ears.
If you're anything like us, you feel like you spend the entire week just drinking from a fire hose of information.
Oh, absolutely. Especially in this space.
Yeah, trying to track the legislative fights, the market structure shifts, and then these like huge foundational infrastructure upgrades all at once.
It's chaos, pure chaos management.
It really is.
And that's kind of the point. I mean, we're not just watching the news, we're tracking these moments where, decades-old financial systems are basically crashing into these future-proof computation models.
Right.
And if you're trying to keep up, you need someone to run triage on that fire hose for you. And that's really why we run the Vocal Technologist.
Exactly. So we've pulled together some of the key things we've seen this week, and the mission is to cut through all of that and figure out what the biggest implications are.
Let's do it.
And I think we have to start where the pressure is highest, which is this regulatory battle over the future of the Web3 market.
Yeah, there's a perfect storm brewing in Washington right now. The whole effort to create a clear market structure for stablecoins is it's in a logjam, a genuine logjam.
You have the Senate Banking Committee and the Senate Agriculture Committee.
Yeah.
And they're both holding markups on their own bills.
On competing bills, which is the key part. So they have to figure their stuff out before they can even look at what the House passed.
Which is the Clarity Act.
Right, the Clarity Act.
Okay, so let's just quickly touch on that. I mean, Clarity is the House's attempt to define what digital assets are, put some under the CFTC, define stablecoins. But it sounds like that whole reconciliation process is not going well.
Not at all. Tim Scott, the Banking Committee chair, he set a hard deadline, January 15th.
Yeah.
And the prediction markets are putting the chance of anything passing before May at only 45%. That just screams fundamental disagreement.
So it's gridlock. And it's a gridlock driven by some really deep, nuanced issues.
It is. And that nuance is already forcing big players to make moves. I mean, look at Coinbase. They just withdrew support for the Senate bill.
After reading the whole 270-page text, yeah.
Exactly. Their concerns were, all over the place. Tokenized equities, how to handle DeFi, the role of the SEC. But the real kicker, the thing that made them pull out?
Let me guess. The stablecoin rewards.
The provisions that would, in their words, kill rewards on stablecoins. That was the line in the sand.
And that yield, that little bit of interest, that's the fault line, isn't it? It connects crypto directly to traditional banking.
It absolutely is. And the specific language is so important here.
Okay, so what does it actually say?
The updated amendment from Senator Scott, it tries to split the difference. It specifically bans any interest or yield for just passively holding payment stablecoins.
Passively holding.
But, and this is the key distinction, it allows activity-based incentives. So rewards you get for actually transacting or staking or posting it as collateral.
Okay, so if you're just letting it sit there like a digital dollar in a checking account, no yield. But if you're using it to do something in the ecosystem, then yield is okay.
Precisely.
That makes some sense from a utility standpoint, but why is TradFi freaking out so much about the passive yield part?
Because they see it as a direct threat to bank deposits. And deposits are the cheapest source of funding for banks.
So they're worried about a bank run.
A slow, methodical one. The community bankers warned senators that if stablecoins could pay interest, it could pull up to $6.6 trillion out of the banking system.
$6.6 trillion.
Yeah.
That is a staggering number.
It is. And their argument is that this would force banks to rely on more expensive funding and then, ultimately you, the consumer, pay for it with higher mortgage and loan rates.
That sounds like the GDP of Japan being threatened by digital dollars. Is that real, or is that just a negotiating tactic?
Well, that's the question, right? And there's a very strong counterview. JP Morgan, of all institutions, basically said that number is way overstated.
Really, JP Morgan?
Yep. They pointed out that non-bank lenders already dominate U.S. credit. They provide most of the mortgages, most of the consumer loans.
So their argument is that this isn't about saving the system.
Their argument is that it's about protecting bank shareholders and their margins by killing a competitor that can offer people a better yield. It's a fight over who controls the next generation of credit.
Wow. Okay, so we've got the U.S. gridlock. Let's pivot for a second to the global compliance landscape, because that's where this stuff is being used in the real world.
Absolutely. The pressure is everywhere. In the UK, you've got Labour MPs pushing to ban crypto political donations completely.
Why now?
It was triggered by a huge £9 million donation to the Reform UK party that was linked back to a major Tether investor.
So the fear is Foreign interference, money laundering.
All of the above. They're worried crypto can hide the true source of political funding, but the even more immediate risk is on the infrastructure side.
You're talking about the Contigo case, the YC-backed fintech.
Exactly. A huge wake-up call. They allegedly violated U.S. sanctions on Venezuela
And how did they do that?
by using U.S. banking rails, specifically JP Morgan and Stripe. They use them to handle conversions from USDC stablecoins into Venezuelan bolivars.
Ah, so even though they're a global fintech, the second they touch U.S.-regulated infrastructure, they're bound by U.S. sanctions law.
And it showed just how quickly that can go wrong. Their partners froze their accounts, off-boarded them almost immediately. The compliance risk isn't just on the user, it's squarely on the fintechs building those bridges.
Which is such a fascinating contrast because while the governments are trying to slow this all down, the actual financial adoption is just exploding.
It's accelerating like crazy. The total market cap for stablecoins just crossed $260 billion.
Which means it's now officially bigger than the total value locked, the TVL, in all of DeFi.
That's the milestone. That confirms stablecoins aren't just for trading anymore. They're becoming the core payment and collateral rail for the whole system.
And you see that in the yield-bearing stablecoins too, the ones being actively used. That's over $20 billion now. The demand for on-chain yield is just massive.
And the big TradFi players are finally making their move. Cautiously, but they're moving. Look at BNY Mellon.
With their tokenized cash.
Right.
But this isn't them jumping onto, like, public Ethereum.
No, not at all. They're starting with collateral and margin, offering 24/7 availability, but with full bank deposit protections. It's a very walled garden approach.
They're using those semi-public permission networks. Why start there?
Well, it's a necessary first step. I mean, they can't just dive into the deep end. Using a network like Canton lets them keep control, maintain KYC/AML, all while getting the benefits of instant settlement.
So it's institutional de-risking. They master the tools there and then maybe push outwards later.
That's the playbook, and we're already seeing this translate into huge retail and cross-border uses. Visa Direct is piloting a program with BVNK's stablecoin infrastructure.
For business payouts, right?
Yeah. Yep. Letting businesses pre-fund payouts in stablecoins for faster global payments that don't have to wait for the SWIFT system.
At the same time, the fight for the actual infrastructure backbone is getting intense. Polygon Labs just spent $250 million.
A $250 million investment to buy 2 regulated payments companies. That is a direct shot at competing in the U.S. market.
And that fits right into their whole open money stack vision, doesn't it?
It's the core of it. Their goal is to build the framework to move all global money on-chain. And they're leveraging their $2 trillion in value transfer history and this thing called the AG layer.
Okay, break that down for us. What is the AG layer, really?
Think of it as like a unifying layer. It uses zero-knowledge proofs to bundle and settle transactions from a bunch of different chains, Polygon, Ethereum, whatever, all together.
So the goal is to make the underlying blockchain invisible to the user.
Exactly. You won't care what chain your money moved on. You'll just see that it was fast and cheap. It's their ultimate scaling play.
All this maturation is now leading to public market validation, which is a huge sign of health.
The BitGo IPO filing, a massive moment.
They're trying to raise up to $201 million at a nearly $2 billion valuation. And they already have $104 billion in assets under custody.
That filing is critical. I mean, BitGo already had conditional OCC approval to operate as a federally chartered national trust bank.
A federally chartered trust bank going public.
That's the indicator of maturity. Custody is the foundation, and the public markets are finally seeing that the institutional-grade plumbing is there.
And the derivatives markets are following right behind. CME Group is expanding again.
Adding futures contracts for Cardano, Chainlink, and Stellar.
Which is a big deal because it's moving beyond just Bitcoin and Ether. Why those 3, do you think?
Well, you have Cardano and Stellar, which are, different takes on L1 payments. And then you have Chainlink, which is the Oracle network. The fact that institutions want regulated exposure to these specific utilities tells you the market is getting a lot more sophisticated. It's valuing the different building blocks.
That's a perfect transition. We've talked about the immediate fights over money and rules, but now we can switch to the really long-term stuff, the foundational tech that will define the next century.
And that really starts with the ultimate requirement, security and durability.
This brings up a pretty philosophical question, right? How do you build a system that's designed to last forever?
It does. And Vitalik Buterin recently laid out these 7 requirements for Ethereum to achieve what he calls ossification.
Ossification, that sounds intense. What does that mean in simple terms?
It means the network gets to a final, hardened state where it can just run forever without anyone needing to intervene. He calls it the walkaway test.
The developers can literally walk away and the system just keeps working.
Exactly. It passes the baton to the governance community. You're designing for true digital permanence.
So what did he list as the #1 priority to achieve that, to get that century-scale durability? It wasn't scaling, was it?
No, it was quantum resistance.
Century-scale quantum resistance.
Yes, correct. I mean, if you build a system today and a quantum computer can crack the crypto in 15 years, you've failed the permanence test. So implementing quantum-safe algorithms is step 1.
And then things like ZK-EVM scaling and statelessness come after that.
All of it aimed at making something that can truly stand the test of time.
Okay, so designing for permanence is one thing, but designing for usability is another. And crypto's biggest hurdle for mass adoption is that everything is public by default.
It's the original sin of blockchain. Your balances, your transaction history, your business logic. It's all out there.
Which is just a non-starter for most real-world finance.
And that's exactly why the work being done on privacy is so critical. We have to have confidential smart contracts. This is where companies like Zama come in, using this technique called fully homomorphic encryption, FHE.
FHE, that is a technical mouthful. How do we explain that?
Okay, think of it like this. FHE lets a computer run calculations on encrypted data without ever decrypting it.
So it's like magic.
It's close. Imagine you put your data in a locked box. You give the locked box to someone, and they can shake it, weigh it, run computations on the box itself, and give you back a new locked box with the answer inside. But they never, ever get to see what was inside the box to begin with.
That is amazing. So the network can enforce the rules of a contract without ever knowing the private details of the transaction.
That's why they call it HTTPS for blockchains. It flips the entire paradigm from public by default to encrypted by default. It might be the most important upgrade since smart contracts were invented.
Wow. Okay, and while that's being built, we saw this totally unexpected win on the performance side this week.
Yeah, a huge one. Ethereum's layer 1 scaling it surged. Daily transaction volume hit a new all-time high, over 2.5 million transactions.
But at the same time, the average gas fee, the cost it collapsed below 1 gwei.
Which for anyone listening is a tiny, tiny fraction of a cent. It's basically free.
So why did fees drop when volume hit a record high? That seems counterintuitive.
It's the cumulative effect of all the recent upgrades, the efficiency gains, but also the massive amount of activity that's being offloaded to layer 2s.
So the L2s are working. They're taking the load off.
They are. And the result is the main L1 chain has become incredibly cheap for simple transfers. And this, practically speaking, it really weakens the argument that you need a layer 2 for just basic, everyday stuff. It makes them more for specialized, high-throughput applications.
And while Ethereum's getting cheaper, the competition is aiming higher. Celestia announced their Vision 2.0.
Yeah, they're aiming to support trading volumes on par with traditional exchanges, which means they need like a 10 to 100-fold improvement in speed. The performance floor is just rising so fast.
Okay, so finally, we have to talk about who the future users of all this new infrastructure will be.
And increasingly, they're not human.
Right. There's this massive push to build environments where autonomous AI agents can operate and transact directly on-chain.
And we're not talking about simple trading bots. We're talking about AIs as independent economic actors.
So what kind of plumbing do you need for that?
You need a trust layer. Ethereum's EIP 8-Haver 04 is trying to build that right now. The idea is to make the network the global coordination layer for these agents.
So it's building registries for agent identity and reputation.
Exactly. An on-chain registry for identity, for a trustworthiness score, and for permissions. You're building the base layer. Some non-human entities can be identified and trusted.
And these experiments are already live. We saw the T54.ai project launch on Solana.
And they claim to be the first fully autonomous agent economy. You have AI agents transacting, negotiating contracts, allocating resources, all without a human clicking send.
It's economic coordination between AIs with the blockchain as the trust layer.
It's a whole new frontier. The infrastructure being built today isn't just for us, it's for the machine economies of tomorrow.
Wow. Okay, so if you just take a step back and look at the whole week, there's this incredible tension.
There really is.
On one hand, you have this immediate, almost existential fight over stablecoin yield. You know, Coinbase versus Congress, community banks versus JP Morgan.
Right.
But then just underneath all those headlines. The foundational technology is just leaping forward at warp speed.
It's astonishing. And if we connect it all back to that challenge of just trying to get a handle on things, the most significant things are happening at that infrastructure layer. The privacy upgrades with FHE, the blueprint for AI economies, the push for quantum resistance.
Those are the things that are going to fundamentally change who uses this tech and what they use it for.
And it all comes back to that idea you mentioned earlier, durability, the walkaway test. You know, we talked about how Vitalik argues that for Ethereum to achieve ossification, to be this permanent, self-sustaining piece of infrastructure, it needs a century-long lifespan model.
It has to be quantum-proof for 100 years.
So if a decentralized platform built for this kind of trustlessness needs that level of resilience to pass the walkaway test, what does that imply about all the other critical digital infrastructure we rely on? Your bank, your cloud storage, your government services?
Are they built to last a century? Are they designed to function if the original developers just disappeared?
Is your digital life, your entire online identity and all your finances, is it truly walkaway safe? That's the question I think is worth mulling over this week.
Spoken Tech for your ears.